could sign I'd appreciate it. Okay, this week we're talking about the female reproductive system, and then next week male, and then we're done. So close. Come see me at my office hours tomorrow. There's my email. And yeah. Okay. So starting with gametogenesis. I hope I'm saying that right. I don't remember, but gametogenesis. So this is the formation of gametes, or sex cells that are haploid. So that just means that they have half the amount of chromosomes than a normal, like, somatic or body cell. The female gamete is an egg, male gamete is a sperm. And then I like that picture at the bottom, so you can just see, like, somatic cell has double the amount of chromosomes, gamete cell has half. So gamete has 23 chromosomes, somatic has 46, and then they come together and form a zygote somatic cell. Okay, so here is the general process for gametogenesis, or forming gametes, the haploid cells. I was going to draw this, but I'm not going to because we're going to focus on hormones because I think it's harder. But so I'll just like talk through this really quickly. You start with a gametocyte, which has 2N, or like it's not haploid, it's diploid, so 46 chromosomes. Goes through mitosis into another gametocyte and a primary gametocyte. Primary gametocyte goes through meiosis 1. Something important to note there is meiosis 1 is when we go from diploid to haploid. So now the secondary gametocytes have half the number of chromosomes, and then both of those go through meiosis 2 into the gametid, and those are all haploid. And then those mature into the gamete, which is either the egg or the sperm. So I know I ran through that quickly, but we're going to talk about hormones. So that'll be helpful for studying. And then I also have the female specific form of gametogenesis, which is known as oogenesis. In males, it's spermatogenesis. So again, I kind of just put this here for when you're studying, like if you want to draw it out yourself, you can reference this. But it's analogous to this flowchart. Just now we have specific names for things that apply to females. Yes, and I also put like I would know the days. So like oogonia mitosis is weeks 7 through 20 of fetal development, and then meiosis of the primary gametocytes is at puberty. Like I would know when the different stages are happening too when you're studying. Okay, so I meant to put it so you guys couldn't see the drawing while I was drawing it. Let me see if I can fix that really quickly. Okay, let's see if it. Okay. So now we're going to talk about female hormonal regulation, or the menstrual cycle. So there are two kind of different ways to think about it. You have the ovarian cycle, which is talking about changes in the follicle, and the uterine cycle, which is talking about changes in the uterine lining. And they both correspond. Okay, yeah, so let's get into it. We're going to draw them both. versus we're going to talk about the ovarian cycle. And there are 3 phases. You have the follicular phase, ovulation phase, and luteal phase. So first is follicular phase. And then within the follicular phase, there's an early, mid, and late subsection. So we're gonna start with early. And I also want to say that this is days 0 through 14. Okay, so the first thing that happens is in the hypothalamus, a hormone is released due to low estrogen and progesterone levels. Does anyone know what hormone is released by the hypothalamus? Does anyone remember? Close. That one's nice. Nope. Good tries though. Those are coming up. Okay, so the hypothalamus releases GnRH. Maybe I should do hormones in the green. Okay, GnRH is released from the hypothalamus when there is low estrogen or progesterone. So, due to low estrogen GnRH stimulates the anterior pituitary gland, and then that's the one that's going to release FSH. So GnRH stimulates anterior pituitary. And now release FSH is also known as follicle stimulating hormone. That stimulates the follicles. Does anyone know what the follicles release? Another hormone. I feel like this is the hardest part of this unit, right? Okay, good. So now we're going to stimulate the follicle. And the follicle releases estrogen. Something to note here is that estrogen released from the follicle stimulates the hypothalamus to release more GnRH. So that's a positive feedback loop right there. So releasing estrogen stimulates the hypothalamus, more GnRH, GnRH stimulates FSH, which stimulates estrogen. So, bless you. Just to symbolizing positive feedback loop, I'm just going to kind of draw like positive feedback. So that's it for the early follicular phase. Now we're into the mid follicular phase. In this phase, the dominant follicle is selected and the rest kind of all wither away, which is known as atresia. So maybe you think like it's mid, they're not good enough, they die. So atresia. Dominant follicle selected. Now into the late follicular phase. At this point, we're building up estrogen because we selected a dominant follicle that's releasing a bunch of estrogen. So an increase in estrogen leads to the LH surge. And LH is another hormone. So you see an LH spike there, and the LH surge is what triggers ovulation, which is the next phase. So we'll do ovulation. Now we're at the second phase, just ovulation. And this is on day 14. And ovulation is when the egg is released from the follicle. So that's pretty much all we're going to have here. Egg, release. And I think I have an anatomy slide up here, so maybe it will be better to visualize. And now we're in phase 3, which is the luteal phase. And this is days 14 to 28. And in this phase, the follicle becomes the corpus luteum. Does anyone know what the corpus luteum releases? It's 2 hormones. /3. Okay, so corpus luteum, so hormones including green, releases estrogen and progesterone. So progesterone is the important one here, but it releases both. And I believe it also releases inhibin. Inhibin. This release of these hormones acts to inhibit the hypothalamus and anterior pituitary glands. So we're inhibiting GnRH release and FSH release. So we're kind of inhibiting the formation of a follicle right now because we're forming the corpus luteum. So these inhibit. Well, I'll make that more clear. Inhibits the anterior pituitary and the hypothalamus. So at this point, if there's no fertilization, so there's no zygote forming, the corpus luteum just like kind of dies, it withers away. So since the corpus luteum causes an increase in progesterone and estrogen, when it dies, those two hormones go down. So when those two hormones go down, we're back here. The hypothalamus is stimulated due to low estrogen and progesterone. So at the end, I'm gonna write like at end, corpus luteum. I'm gonna write dies, but you've got, and it doesn't actually like die. It just kind of withers away. Which causes, I'll just keep doing that, decrease in progesterone and estrogen, which stimulates the whole thing again. If fertilization did occur, this would continue to develop an estrogen, or progesterone and estrogen would increase. During pregnancy. Does anyone have any questions on the ovarian cycle so far? Or is that pretty clear? Okay. So next is the uterine cycle, and it's kind of just what's happening in the uterus while this is happening. So I want to do it kind of like directly under it because it corresponds to the same hormone release. So it's going to be kind of cramped up under it, but we're going to try. So second, is the uterine cycle. Okay, I'm using red again, but they're not related. I only have like blue. So first we're going to talk about the menstruation phase. Can you guys see that? Okay. And this is days 0 to 7. That's okay. So it's half of the follicular phase. This is when you shed the stratum functionalis, which is the inner layer of the endometrium of the uterus. So that's on this. So it's just like the inner, I guess there are 2 layers of the endometrium, the functional layer and the basal. You're shedding the functional layer of the endometrium. That's all we're going to put there for now. Second is the proliferation phase, which I'm just going to put up here so you guys can see it better, but it's still in the uterine cycle. That's all uterine. Proliferation phase, and this is days 7 to 14. So we're in the second half of the follicular phase when talking about the ovarian cycle. The estrogen that was increasing due to that dominant follicle. Helps to regrow the stratum functionalis that we just shed. So increasing estrogen here is regrowing the endometrium lining. So estrogen, increasing estrogen regrows layer. Regrows the endometrium layer. Then on day 14, ovulation happens. So it ends at ovulation. So the egg is released from the follicle and starts becoming the corpus luteum in the luteal phase. So when that's happening, progesterone is increasing. An increase in progesterone causes a release of nutrient broth, which is to support the developing embryo potentially. So 3 is the secretory phase. And this is days 14 to 28. The increase in progesterone causes the stratum functionalis, which is just the endometrium layer, to release the nutrient broth. Nutrient broth to support the potentially developing embryo. Again, if there's no embryo, the corpus luteum is going to wither away, progesterone is going to decrease, and then we're going to start the cycle all over again. Okay, so here's that from my notes, what I have, so you can see it if you want to redraw it. What do you guys think? Is that clear? Do you have any questions, or that makes sense? And I make it so you can't see the drawing again while I draw it. So next I was planning on doing the same thing, but drawing like I'll give you a preview, like the hormone levels, so you can kind of like put it together even more. I would want to put them on the same slide so you can look at it all together. But this is available for you so you can look back to it after. So I'm going to have to erase it and do it separately. So this is going to be the corresponding hormone release to these two cycles. Is everyone good with this? Can I erase? Okay. So we're going to look at the hormones released from the anterior pituitary gland and the ovary. So starting with the anterior pituitary glands. Just to help you guys remember, we talked about that the anterior pituitary is stimulated by GnRH. Yeah, GnRH. And then it releases FSH. And it eventually releases LH. So we're going to draw like that. So this is going to be ovulation, and the middle, which is day 14, which means that this is the follicular phase. Phase 1 day 14. So then this is the luteal phase. So remembering from last time, or last drawing, low estrogen and progesterone stimulates the hypothalamus, which causes an increase in GnRH, which stimulates the anterior pituitary to release FSH. So when estrogen and progesterone are low, we have some FSH, which I'm doing in green, released. So it looks kind of like this, kind of is released because estrogen and progesterone are low. Estrogen starts being produced because follicles are growing due to the follicle stimulating hormone, which inhibits it, so it kind of dips and goes down. So there's an FSH dip. And then it comes back up with LH, as we're going to draw in a second. And then during ovulation, dips here. So that's what FSH looks like. And if you remember, the corpus luteum is releasing progesterone and estrogen, which are inhibiting FSH. So that's why it's low in the luteal phase. LH is pretty easy, it's constant the whole time, except the LH surge is during ovulation, and that stimulates ovulation. So this is LH, looks kind of like that. And if you remember, the LH surge is triggered by that increasing estrogen from the dominant follicle. So we can label this as LH surge. And then we can also write, right here, there's an FSH dip. How are you guys feeling about this? Are you making the connection, or is it, I feel like this is really hard to conceptualize. Makes sense? A little bit? Yeah, I feel like when I was going over this today, I like kind of talked through it a few times, and now I feel like I get it. But the first time is definitely like hard to wrap your head around. But I think this is the hardest concept in this unit. So next we're going to draw the corresponding hormones in like the follicle. So right, follicle. We'll draw the same. And then again, that's ovulation. So this is just carries down. first talking about estrogen. This might be easier to understand than the previous one. So estrogen levels kind of gradually increase. Remember, FSH stimulates the follicle stimulating hormone. The follicle releases estrogen. So we're stimulating the follicle, which is causing this estrogen to increase. And then in the mid-follicular phase, the dominant follicle is selected. Estrogen increases high. And then ovulation happens, and the corpus luteum starts being formed. So there's a dip in estrogen, and then the corpus luteum begins releasing estrogen also, so then it increases a little bit, and then it goes down. So this is due to the corpus luteum. This is due to the dominant follicle. And then we just have one more hormone to talk about, progesterone. So this one's a little bit easier to conceptualize too. It's constant, no progesterone until we're forming the corpus luteum, and that's when it starts to increase because the corpus luteum releases progesterone. So this is also due to the corpus luteum. Again, once we have low estrogen and progesterone, that stimulates GnRH, which stimulates FSH, which starts it over again. So I'll label these as progesterone. And estrogen. Okay, so I have a few more notes to try to make it make more sense, but do you have any questions right now? Okay. So a few trends I wanted to point out to maybe make it less confusing is I keep talking about GnRH and FSH. I'll write them over here. GnRH and FSH are directly related. When GnRH is released by the hypothalamus, FSH is then released by the anterior pituitary gland. So I'm just going to write that they're directly related. Okay, so this next part is confusing. So estrogen both stimulates and inhibits the release of FSH at different parts of the cycle. I don't know if you noticed me saying that. So there's a threshold, and when estrogen is above or below a certain threshold, it either, like, there's an inverse relationship. So I'm going to write that down, and then we can talk about it to make more sense. So at low levels of estrogen, FSH and GnRH and estrogen are inversely related. So that would correspond to right here. Estrogen levels are low, So that means there's an inverse relationship between estrogen and FSH. So low estrogen, that's why estrogen is increasing here and FSH is decreasing. Inverse relationship at low estrogen levels. Sorry for that. At low estrogen. So at low estrogen levels, estrogen and GnRH/FSH, so I'm just going to write FSH, are inversely related. So in other words, when estrogen is low, increasing estrogen inhibits FSH. Estrogen is low, increasing inhibits or decreases FSH. Or inhibits. At levels of estrogen above this critical value, there's the opposite relationship. So at high estrogen, increasing estrogen stimulates FSH. So they're directly related. And you can see that here, estrogen is really high and LH is really high. So estrogen is above some critical estrogen value to a point where it stimulates FSH. So something else to note is, like, memorizing this isn't going to help you, but being able to reason through what's happening, like here, progesterone and estrogen increase because the corpus luteum is developing, and then it's withering away, so they decrease, which causes the hypothalamus to release GnRH, which causes the release of FSH, and like talking through it like that will help. But this is like the hardest thing, so I wanted to try to like make it make sense. But if it's confusing right now, like, that's okay. So here's that. Here. And then I have it all together here, so you can look at like the words with the hormones, the pattern of the hormones. And then I just threw this on here so you can see like where we are when the follicle is released, how it's going into the fallopian tube, and then we talked about the uterine and the uterine cycle, how that relates to like the changing in the endometrium layer in the uterus. And then also relating the hormones to like what's happening. Looking at this like kind of flow chart is helpful. So we can come back and talk about that if we have time, but I want to get to the top hat questions because they talk about, or they're about what we just discussed. Okay, so first one. The LH surge triggers what phase of the ovarian cycle? Okay, so I was going for ovulation here, but it kind of does indirectly trigger progesterone release because I'd say ovulation is the best answer, but the second best would be progesterone release because after ovulation, the corpus luteum is starting to be formed, which releases estrogen. But the LH surge directly triggers ovulation. Increasing GnRH from the hypothalamus has what effect on the hormone release from the anterior pituitary gland? Nice. You all got it. So when GnRH is released from the hypothalamus, it triggers the anterior pituitary to release FSH. For some of them, I put little explanations. If you go back to these. Oh, let's fix that. So this one is at estrogen levels below a certain threshold, increasing estrogen does what? This one's kind of tough. So that corresponds to this point here. When estrogen levels are low, there's an inverse relationship. Above the thresholds, there's a direct relationship. Okay, we got a pretty good spread. So when estrogen levels are low, there's an inverse relationship between estrogen and FSH. So that means increasing estrogen below this threshold would decrease FSH. And we see that here. So say that's like the threshold for estrogen. Estrogen is low, it's increasing. FSH is decreasing here. Here, we're above the value, estrogen is increasing, FSH is also increasing. So that is why that's the correct answer. This is really specific and I wouldn't worry about this too much. This is a hard question. I'm just like emphasizing it so you can like when you run through this, you can completely understand all the trends that's going on. Okay, so this is the opposite. At estrogen levels above a certain threshold, increasing estrogen causes what? So we're above the threshold, increasing. There's a direct relationship. Nice. The corpus luteum that develops in days 14 to 28 of the ovarian cycle releases what? Perfect. I believe it also releases inhibin, but I didn't talk about that, so I don't think that those are the only two hormones that it releases, but those are the main ones. The degrading corpus luteum causes what? And what effect does this have on the menstrual cycle? Choose two. I don't know if you can't choose two, but there are two correct answers. I don't know how to change it, but just guess, I guess, in your head. Okay, let's see what you guys said. Okay, so I feel like we agree that the degrading corpus luteum causes estrogen and progesterone to decrease, which corresponds to right here. So we're spread on what effect this has on the cycle. Decreasing progesterone and estrogen either stimulates or inhibits the hypothalamus. What do you guys think? Does anyone have an idea? Well, okay. So decreasing progesterone and estrogen stimulates the hypothalamus to release GnRH. Which again, when GnRH is released, we release FSH, which then causes the release of estrogen. So I can write that. So that leads, we kind of start the cycle again. Decreasing progesterone and estrogen leads to increasing GnRH from the hypothalamus, which leads to increasing FSH from the anterior pituitary, which leads to increasing estrogen from the follicle. And then you have ovulation, formation of the corpus luteum, and the corpus luteum then causes an increase in progesterone and estrogen. And then it withers away and it decreases, and then we're back here. So that's like kind of a different flow chart way of thinking of it. This is the corpus luteum. And this is ovulation. So that's why C is the correct answer for the effect that it has. Fertilization occurs in the, and this is a specific anatomy question that I didn't go over, but let's see if you guys got it from the videos. Okay, since we only have a little bit of time left between a few, so the correct answer is the ampulla. That's this region right here. Fertilization occurs in the ampulla. Yeah, so I guess that's just an extra thing. Let's see what. Thank you. If fertilization occurs, what happens? This is kind of where we're talking about. Oh, nice. Perfect. You guys got it? Increasing estrogen during the late follicular phase corresponds to what phase of the uterine cycle? This is a tough question here. Okay, so increasing estrogen corresponds with building the stratum functionalis, which is the proliferation phase. The menstrual phase, I believe, is triggered by low estrogen because it's at the beginning of the follicular phase. And then the secretory phase is triggered by an increase in progesterone that leads to that like nutrient broth. Okay, last one. An increase in progesterone corresponds to what phase? And that's the secretory phase. And we're out of time, so you guys are good to go, but yeah, ask me questions. Thanks for coming.